Good afternoon, everyone. Today we're going to look at some transformations on a general function f of x that has a point on -3 and 4. Okay, so the point at -3, 4 lies somewhere on this original function f of x. We don't really know what the rest of it looks like, but we do know it goes through the point -3, 4. Now, f of x is going to undergo a bunch of transformations, so much so that it ends up looking like this and giving rise to a new function, let's say, being called 1/2 of the original f function, but now it's 1/2 of f of 1/2 of x minus 2, and then at the end plus 3. And so if you want to know what transformations are taking place here, how the point at -3, 4 is going to get moved around, let's say, then let's have a look at those individual transformations on f of x. First off, the value in front of f at the very front is our vertical stretch. A vertical stretch of 1/2 means that any point on the original function f of x becomes half as far away from the x-axis as it used to be. So wherever it is in relation to the x-axis, it now is only half as far away as it used to be. Okay. Now, this 1/2 inside of the brackets, inside of the f function, and factored out front of the x, this 1/2 gives rise to a horizontal stretch, but it's given as the reciprocal of the horizontal stretch. So the horizontal stretch is the reciprocal 1/1/2. And so that means that the horizontal stretch that took place was a horizontal stretch of +2, meaning that now in the x direction, a horizontal stretch, any point on the original graph of f of x is now going to be twice as far away horizontally, twice as far away from the y-axis, twice as far away from it as it used to be. Wherever it was in relation to the y-axis, it's now twice as far away in the end. Next, we have our translations. Inside of the brackets, alongside of the x, we have our horizontal translation. It's attached to the x, so we flip the sign, and so x minus 2 means a horizontal translation of +2. And then finally, at the very end outside, just like the vertical stretch was outside, the vertical translation is outside at the very end, and that's a vertical translation of +3. And so now, every point on the original function f of x, meaning the original function f of x itself, is undergoing a vertical stretch of 1/2, a horizontal stretch of 2, a horizontal translation of 2, and a vertical translation of 3. And now that means that the point -3, 4 is going to get mapped. We say get mapped because it's going to undergo a bunch of transformations, and it's going to end up somewhere else on the graph, right? In this new function. Now, the first thing that's going to happen is to the y-coordinate, to its y-coordinate of 4, it's going to undergo a vertical stretch of 1/2, meaning that it's going to be only half as far away from the x-axis it used to be. So it used to be 4 units away from the x-axis. A vertical stretch of 1/2 means it's now only 2 units away. So we'll take 1/2 of 4, 1/2 of the original y-coordinate. And now after that, we're going to apply a vertical translation of 3, meaning wherever that ends up, we now shift it up by 3, right? And just like BEDMAS, we do our multiplication first, and then we do our addition. So we add 3 units at the very end, and so we'll do a +3 at the tail end. Similarly, for the x-coordinate, now our horizontal stretch is a factor of 2, so the x-coordinate is going to be twice as far away from the x-axis as it used to be. And so we apply the horizontal stretch of 2, the x-coordinate of -3, and so the new x-coordinate is going to be 2 times -3, twice as far away from the y-axis as it used to be. It'll be at -6. And at the end, we apply a horizontal translation of 2, meaning we shift it 2 units to the right in the positive direction at the end. And so just like BEDMAS, we multiply first, and then we add or subtract. And so this is how this original point that lies somewhere on f of x is going to get transformed. Transformations, that's what they do. And we find that this original point, -3, 4, that was on the original f of x, is now, under this function, moved to the position 2 times -3 is -6, plus 2 is -4, and 1/2 times 4 is 2, plus 3 is +5. And this would be the location of our new point, where it was originally here, but now, under this transformed function, is in this position. And that's how transformations work. We have stretches, we have translations, And just like BEDMAS, we multiply first and add or subtract afterwards. So I hope this helps, and thanks for watching.